Today we're going to be matching equations to graphs. So to do that, what you need to do is to find a couple of points on the line of the graph and substitute those coordinates into your equation and see if they match. Now you have to do it for more than one value to make sure that it is a match. But if it works for two, then it will work. So let's just see if this one works. So you want to pick easy points. So right here, 1, 3. Okay, so my coordinate is 1, 3 for that one. And for this one is 2, 6. Now, remember, when you have coordinates, the first value is your x value. The second value is your y value. So I'm just going to put these points into this equation right here and see if the left side equals the right side. So my y value for this one is 3 equals, this 3 stays the same, 3 times 1, because my x value was 1. Well, 3 does equal 3, so that works. Okay, let's try it again for the other one. So my y value is 6 equals 3, and my x value was 2. So since 6 equals 6, so this graph right here, the line, is for the equation of y equals 3x. So this is one way we're going to solve these problems. So I have 3 equations here and I have 3 graphs. I need to match each equation with each graph. Okay, so what I'm going to do is I'm going to pick some easy points. Now I need to do at least 2 points. So I could pick this one and I could pick this one, or I could pick one on one of the x-axis or y-axis. That would work too, because those work out well too. So if I did, let's just choose this point right here. So my value is 2, 1. Okay, so I'm just going to sub it into my first equation here. My y value is 1 equals 3 times 2, because 2 is my x value, plus 3. Well, 1 does not equal 6 plus 3 is 9. So I know that graph A is not that equation. Okay, let's try. I don't have to do a second point if I already know it doesn't work out. So let's try a different equation. Okay, let's try x plus y equals 3. Well, x is 2, so 2 plus 1, it does equal 3. So that one works for that equation. Now I just need to do one more because I have to make sure. So this point here would be 1, 1, 2, which 1 plus 2 also equals 3. So I know that graph A is this equation right here. Okay, so now I can move on to graph B. So graph B, I'm going to choose this value right here. And that is 2, 3. Okay, so let's try this first equation for graph B. So my y value is 3. So 3 equals, that would be 3 times the x value of 2, and then add another 3. Well, I know that that's not true either. That doesn't work. So I know that graph B is not that equation right there. So graph B would most likely going to have to be this third equation, but we should check it just to make sure. So if I do 3 is my y value equals 3 times 2 minus 3. So that would be 3 equals 6 minus 3, which does work out. So graph B is that one. So therefore graph C is most likely going to have to be the first one, but we should check and make sure. So I could use this point right here. That point is 0, 3. And this point right here, which is 1, 6. So y3 equals 3 times 0 plus 3, which does work out. Try the other one. 6 equals 3 times 1 plus 3, which also is 6. So this would be y equals 3x plus 3. So we matched them all up. If you wanted, you could just take your equation and actually graph it, create your table of values, x, y, graph it and see which line it matches up with. That would work. Or we could just pick a point again and see which one works. So we could pick, for the 2, the origin, and see if that works out. 0 equals 3 times 0 minus 4. Well, that doesn't work. So we can eliminate that line. Okay, we need to pick some more lines here. So let's pick this point right there. That point is 0, 2. So y is 2 equals 3 times 0 minus 4. Well, that doesn't equal. So I know that it's not that one. So by process of elimination, I know it's the other one, but let's just check it. So that point is 2, 2. So 2 equals 3 times 2 minus 4. 2 equals 6 minus 4, which is true. So it would be line 3. Okay, I want you to try these. So match up the graphs with their lines. Make sure that you don't use the origin as a point, because that actually works for every single equation. That's why you normally have to choose 2 points in case 2 graphs share the same point by intersecting at them. So in this case, don't use that one, but if you use other values, such as that one, and that one, then you know that they're all different points and those will work. So match those up. I will go over it in a minute. Okay, so the first equation is y equals x. So the x and the y value have to be the same thing. So let's just think about this one logically. This point right here is 2, 2. Well, the x does equal the y, and that is not the case for any of the other equations. So this one would be graph C. Okay, this point I have here is 2, 4, and this point is -1, 3. Okay, so if I tried this one, -1, 3, so 3 would equal 2 times -1. Well, 3 does not equal -2, so that one doesn't work. So the green line graph B does not work for y equals 2x. So that means it must be graph A, but let's check it to make sure. So 4 equals 2 times 2. Well, that's true. So this one would be A. This one would have to be B, which makes sense because if I had that -1, 3, y is 3, so 3 equals -3 times -1, which is true because -3 times -1 is +3. So that's how we can match up graphs to their equations.